Recently, the sun has caught the attention of scientists due to its unusual behavior, sparking concerns about its potential impact on our technology. Some extraordinary events have been occurring, including the formation of giant holes, swirling polar whirlwinds, potentially dangerous coronal mass ejections, and massive solar flares. These occurrences are not entirely new, as the sun has been going through natural cycles for billions of years. However, what makes this period stand out during the solar maximum is the advanced technology that we have to our advantage, which allows us to closely observe and record these strange happenings. The sun goes through an 11-year cycle, transitioning between high and low activity phases. As we approach the next 2 years, we are currently heading toward the apex of the solar cycle. One intriguing incident happened in February 2023, when a massive tentacle of plasma suddenly snapped apart in the sun's atmosphere. Spiraling down, it encircled the star's north pole at an astonishing speed before disappearing. This strange event lasted approximately 8 hours and became an internet sensation after a science communicator and researcher named Tamitha Skov shared footage of it on Twitter. NASA's Solar Dynamics Observatory captured the video. On another note, this polar vortex is not a new concept on Earth. Scientists first described it in the 1800s, and it has been present since the formation of our atmosphere. For a few years now, the term polar vortex has become popular in weather forecasts and the media, particularly from 2013 to 2014. Interestingly, polar vortices have also been observed on other celestial bodies during our exploration of the universe. Spacecrafts and cutting-edge telescopes have allowed us to witness them on Mars, Venus, and Jupiter. Even Titan, Saturn's moon, seemed to experience this fascinating phenomenon. Recently, scientists have been highly interested in new developments related to the sun. One fascinating occurrence that caught their attention is the polar vortex. This happened when material from the northern prominence of the sun's surface broke away and formed a huge swirling structure. Such structures are common, and they can stretch for long distances along magnetic field lines due to solar plasma following them. What this means is that when a strand of plasma, composed of charged gases found in all stars, erupted with great energy, it gave rise to a looped structure known as prominence. While these beautiful formations are relatively frequent, they can extend for thousands of miles into space. As they gracefully glide along magnetic field lines, the solar plasma creates a beautiful celestial display. What made this particular event intriguing was that its prominence didn't vanish right away, unexpectedly. Instead, it hung around for hours, swirling around the north pole of the sun, resembling the polar vortex observed on Earth during winter. Solar physicist Scott McIntosh was surprised by this behavior, as solar plasma has never exhibited such behavior previously. However, McIntosh also observed that long filaments tend to erupt close to the 55 degree of the sun's latitude lines, which is coincidentally where this unusual prominence was seen. These filaments become more common as the sun's 11-year activity cycle approaches the solar maximum, which is a time when magnetic activity reaches its peak. It is during this time that the magnetic field lines of the sun entangle and whip around each other with very high frequency, and this causes sunspots and massive spews of plasma into space. Scientists predict that the next solar maximum will occur in 2025, and there has been a noticeable increase in solar activity recently. Although plasma filaments themselves are not intimidating to Earth, erupting filaments can cause the release of massive, fast-moving blobs of plasma and associated magnetic fields, known as coronal mass ejections, CMEs. The Space Weather Prediction Center of the National Oceanic and Atmospheric Administration warns that if one of these charged blobs, known as coronal mass ejections, were to pass over Earth, it could potentially harm satellites, causing power grid failures, and even lead to the occurrence of colorful auroras at lower latitudes than usual. To better understand its formation and potential consequences, further research is needed, as emphasized by scientists. Moreover, for the first time, we have the opportunity to closely observe a solar maximum in high definition, thanks to advancements in observational technology. On March 20th, 2023, two large coronal holes appeared on the surface of the Sun. These are areas where the Sun's corona is thinner and a little colder, thanks to open magnetic field lines that enable plasma to escape into space. Although these holes usually occur near the poles of the Sun, they were also observed at lower altitudes during the recorded times of reduced solar activity, as observed in March 2023. Coronal holes have the potential to affect Earth by producing high-speed streams of solar wind. By interacting with the Earth's magnetic field, they can enhance geomagnetic activity and lead to spectacular auroras in specific regions. They also influence cosmic rays entering the solar system. The solar wind is mostly made up of electrons and protons, along with trace amounts of helium and heavier ions. Its temperature, speed, magnetic field, density, and strength depend completely on the conditions on the Sun's surface. When the solar wind interacts with Earth, it can influence and compress the planet's magnetic field, resulting in the formation of a bow shock ahead of it, therefore transferring energy and momentum to Earth's ionosphere, upper atmosphere, and magnetosphere, impacting their chemistry and composition. However, due to the limited dynamic range of sensors, observing and recording the Sun's surface poses significant challenges. While coronal holes are relatively common, they are typically observed in the Sun's polar regions. This concept is similar to the challenges of capturing extremely bright light with a phone's camera. When attempting to capture the brightness of these holes, the surrounding portions of the image appear notably darker. These coronal holes occur quite frequently, primarily near the Sun's polar regions. The reason we don't usually see the effects of coronal holes on Earth is that the solar wind, carrying the ejected plasma, generally flows either above or below our orbital plane and continues into space. However, if one of these coronal holes faces Earth, the high-speed plasma is directed toward us. These solar winds can reach incredible speeds of 800 kilometers per second, equivalent to about 1.8 million miles per hour. Luckily, there's no need to worry, as they don't pose an immediate threat to us. Studying events like the polar vortex helps us understand how the magnetic fields of the Sun work. During solar cycles, one significant event is the flip of the magnetic field's polarities. Observing the polar vortex may indicate that this change has begun once more. Although most Sun-related events are not as volatile and destructive as they may seem, it's crucial to stay alert to potential concerns. With a solar maximum approaching, we can expect more solar flares, coronal mass ejections, and sunspots, which have had crucial impacts on Earth in the past and will continue to do so in the future. Sunspots, in particular, can be quite risky as they lead to solar storms, resulting in coronal mass ejections, massive bursts of plasma and magnetic energy traveling through the solar system. On April 6, 2023, a report indicated that there are currently 3 major sunspot groups developing, and 2 of them have the potential to pose a threat to Earth. Among these groups, the AR3270 has expanded tenfold over the past few months and contains 2 dark cores, each approximately the size of the Earth. The overlapping magnetic fields from these cores create highly unstable conditions, leading to thermal combustion on the Sun's surface and resulting in massive flare eruptions. It is important to note that these sunspots carry a 5% chance of producing an X-class solar flare, which represents the most potent category. The strength of these solar flares is also measured very similarly to how earthquakes are measured. These solar flares range from the B class to the C class, the M class, and lastly, the X class. The X class is by far the strongest class of solar flares. In April 2022, a massive solar eruption occurred on the Sun's surface, potentially sending a solar storm toward Earth. The eruption originated from an area called Region 2993, which was directly facing Earth and happened around 9:55 p.m. Eastern Time. Classified as an M9.6 flare, it almost qualified in the class of the most powerful X-class solar flares, but still ranked as one of the strongest, as it was at the upper end of the M-class scale. Radio signals were caught by space weather detectors, and it was linked to the flare, suggesting the occurrence of a coronal mass ejection. This huge cloud of charged solar particles has the potential to affect electronics on Earth if the coronal mass ejection is powerful enough. Such flares have the potential to cause massive destruction to communication and satellite systems, posing risks to our technological infrastructure. The earlier mentioned sunspot observations are sourced from a satellite known as the Deep Space Climate Observatory, or DISCOVER, which is positioned at the L1 Lagrange point, benefiting from a stable location with neutral gravity in space. This unique position enables the satellite to maintain a fixed relationship with both the Earth and the Sun, ensuring the consistent and accurate monitoring of sunspots. Observing these solar events from Earth presents challenges due to the Sun's round shape. While images from NASA SDO points at the plasma stream looping about the pole, obtaining a vivid image of this event close to the poles can be tough. However, we also await observations from the solar orbiter satellites, as they are expected to provide us with a far clearer view of the Sun's poles. As this satellite approaches Venus, the Fly is going to give it gravitational boosts, gradually tilting its orbit to capture improved views of the Sun's northern and southern polar regions. In today's age, we have a special opportunity to watch our Sun's activities in real time, thanks to modern technology and the internet. Despite being essential for our existence and survival, the Sun continues to amaze and surprise us, reminding us of the vastness and complexity of our solar system. And that brings us to the end of this video. If you like this video, click on the screen to watch other videos like this one. Don't forget to like, subscribe, and click on the notification bell to get notified when we post a new video.